My topic today is the emerging pollutants in surface water, membranes-based technology. Our time today will be talking for what's emerging pollutants, the role for the membranes-based technology, and the obstacles facing it, and its remediation. Finally, our concluded remarks. Okay. So we will begin with our first point. What's emerging pollutants? Emerging pollutants as a class of contaminants, one of the important threats for human health and for the ecosystem, which need to be monitored and regulated. As a current view for these pollutants or emerging pollutants, what are emerging pollutants? This is the question. We are talking about pharmaceuticals, antibiotics, disinfectants, anti-inflammatory, some of the products which comes with the personal care products. اتفضل هنا ده اتفضل مع النور. Sure. So the personal care products, one of the antibacterial soaps are one of our target now for the emerging pollutants. And they are going to the traditional and conventional way for the treatment, which sure is not effective. Also, the persistence and the bioaccumulation for these products and the adverse effect on the human health and the biosystem as we found. Antidepressants, hormones, sunscreen agents, all of these are from the personal care products and from the examples for the pharmaceuticals or the emerging pollutants. Another cluster of the emerging pollutants is the PFAS products or the substances which is found in many of the cooking ware, like the tefal, like the plastic bottles, all of the daily life products which all of us are using in their homes or in their life. When we are talking for the emerging pollutants, we can't talk about we can't move without talking about the microplastics. The microplastics which comes from the synthetic clothing fibers, the microplastics which comes from the tire wear, the microplastics which comes from many things and go to the ocean, go to the sea, and takes more than 400 years to get rid of, and so causing a great problem for this. When we are talking also for the emerging pollutants, we are talking for the nanomaterials. Many nanomaterials are being used in many products or many activities, and they have a great potential of human health effects and environmental persistence. Also, the presence of the pesticides, its metabolism, and the transformation products, many harmful compounds. Also, the flame retardants comes from the substance which take the way for the potential for carcinogenic. Some drugs which is used for releasing the pain or for decreasing the pain also have many presence for in the aquatic toxicity limits which is formed and causing also potential human health. And more, but we still have insufficient knowledge. We still have a widespread occurrence for this to be detected and to be treated. When we are talking for the role for membranes-based technology, we are talking for a great cluster for using these technologies. We are using these technologies for several advantages over the conventional treatment methods. For sure, it begins with the high removal efficiency of such membranes when we are using the reverse osmosis, where some of these personal care products or some emerging pollutants are very, very small to be detected or to be removed by membranes, which is higher in size than the reverse osmosis. Others need the nanofiltration, others need the membrane bioreactors. And so we need to have a system which have a high rejection rate, which is found and can be easily tailored by using membranes. Also, one of the great advantages for the membranes is the versatility and adaptability, as the membranes can be tailored, as we said, for the pore size, for the material, for the surface properties, for the antibacterial and anti-fouling abilities, as we can see in many presentations today and tomorrow through this conference. Also, we have the resistance here for transformation products. The membrane processes can effectively remove not only the parents of the emerging pollutants, but the transformation products means that after a while, the emerging pollutants is found in the surface water, in the groundwater, or even if in the soil, it was going to transformation or change in the structure. So the membrane will be able to take this structure or to get rid of these compounds. The compact and the modular design also, the integration and other treatment technologies, that the membrane is easily being coupled with other techniques like adsorption, biological treatments, or advanced oxidation processes. Here we can have some examples for the membrane-based technologies for emerging pollutants. Sorry. Also, one of the important obstacles is the operational and maintenance challenge. Reliable and efficient operation for these membranes is important for the sustainable treatment or separation processes. Also, the concentrate management and disposal present one of the great challenges, especially when we are talking for the emerging pollutants. This means that after separating these emerging pollutants, if going back to the soil or going back to the surface water, means the problem is being repeated again by more concentration and getting more problems. So the proper management and disposal of these concentrate streams is critical and very important to prevent this release again. So this goes with us to the concluded remarks that a lack of standard protocol and regulations, monitoring regulations for these emerging pollutants still in the early stages. I'm not talking for Egypt only, but for many, many areas all over the world, that the tracking or the monitoring or the regulation of these emerging pollutants still needs a lot of work. Also, developing comprehensive regulatory framework for these standardized protocols for the assessment management can facilitate the widespread acceptance and the implementation of these membrane-based solutions. Overcoming these obstacles requires many advanced treatments, many work research, applied research for the membrane materials design for this, and the development of robust pre-treatment technologies, which will serve for decreasing the maintenance, for decreasing the fouling, decreasing the problems, for paying a lot of money for these membranes. Also, effective concentrate management needs a lot of comprehensive regulatory framework to be installed for the infrastructure for this treatment system, how to go with this concentrate to extra treatment or post-treatment, which will serve for getting these emerging pollutants out of the environment, not going back with the same properties or the same problem and come back to the environment. Collaborative efforts between the researchers and the policymakers and the industry stakeholders will present the greatest challenge and unlock the full potential for the membrane technology and its remediation. And so this will go for us for the contribution for the protection of the water resources, for the overall sustainability and of water management practices. Thank you.